Hey guys, this is Mrs. Lyons. I am going to, this video is going to go through our notes on limiting reactant and percent yield. These are notes we took in class, but if you need to revisit it or if you were absent, this is what you need to know. So let's get going. Theoretical yield. Okay, this is what we've been calculating when we've been doing those two limiting reactant problems. Okay, theoretical yield is defined as the amount of product that can be formed if all of the limiting reactants is used up. Okay. And then we have a term called the actual yield. Okay. And the actual yield is the amount of product formed in a chemical reaction carried out in the lab. Okay, so the main difference, the big difference in these two things is that the theoretical yield is calculated and the actual yield is measured, okay, by doing a lab. All right, so that's the difference in those. And once we have a theoretical and an actual yield, we can calculate our percent yield. And I like to compare the percent yield as the grade that a chemical reaction gets, because what we're looking at is it's kind of like when you take a test, okay, you get a score and you take your score divided by the total, by the best possible score, and times 100, and that gives you your grade. The same thing is going to be true about a chemical reaction. When we've done a chemical reaction, we can measure the yield and then compare it to what we should have gotten. Okay, so a percent yield should never be over 100%. If you're doing an experiment in the lab and you get a percent yield over 100%, you'll have to figure out what went wrong with your equation, with your experiment. If you're calculating and your percent is over 100, it might mean that you've calculated it incorrectly, or it could mean that your chemistry teacher didn't do the problem before she printed out the handout. I've tried to make sure that that doesn't happen on this worksheet. All right, so let's look at this equation. Suppose 6.3 grams of HCl, might as well underline while we're there, 6.3 grams of HCl reacts with 2.8 grams of calcium hydroxide. Okay, how many grams of calcium chloride will be formed? Okay, so this is what we're looking for. We're looking for our unknown calcium chloride. And we have calcium hydroxide and hydrochloric acid, HCl, to start. Okay, the first thing that we need to do is we need to balance this equation. And one of the things that I always say when balancing equations with water is instead of having H2O, to write this as HOH. And if you've watched me do this before, the reason I say that is it balances more easily because our hydrogens come from this, the HCl, and our OHs, our hydroxides, come from these hydroxides. Okay, so it just makes it easier to balance sometimes when you don't have to kind of count all of the hydrogen together, since there's hydrogen in two places. Okay, so if we look at this, I have two hydroxides. Over here, I only have one. So I'm going to put a 2 here. Now I have two hydrogens. I also have two chlorines. So if I put a 2 here, my equation's balanced. Okay, now we're going to do 2 gram-to-gram problems. All right, the first problem we're going to start with 6.3 grams of HCl. Okay. And our first step is always going to be to convert grams to moles. Okay, so our grams of HCl are going to come down. We're going to have to look at our periodic table for the molar mass. And then on the top, we have 1 mole of HCl. Okay, so where's my periodic table? If you don't have your periodic table out, go grab it and a calculator, pause the video and come back. So we have HCl, hydrogen is 1.01, chlorine is 35.45. So if I add those together, hydrogen's 1.01, chlorine is 35.45. So our molar mass for HCl is 36.46. So that goes right here. Okay, now for canceling units as we go along, we can cancel grams of HCl. All right, our second step is always our mole ratio step. Okay, so this is where we are going to have moles of HCl on the bottom, and then moles of what we're looking for on the top. Okay, so you want to make sure that you don't mix up what you need. You need the moles of what we're trying to find, so calcium chloride. All right, and then we use our coefficients, so we've got 2 HCl and 1 CaCl2. All right, oops, and canceling our units, moles of HCl cancel out. All right, and then our final step is to convert between moles of calcium chloride and grams of calcium chloride. So in this one, we have 1 mole of calcium chloride on the bottom, and we have grams of calcium chloride on the top. And we have to look at the mass of calcium chloride. So calcium is 40.08, and chlorine is 35.45. So we're going to add that all together. Didn't leave myself enough room. I'm going to get 18, 9. You know what? Let's be smart about this. Let's use a calculator. All right, so 40.08 plus 35.45 plus 35.45, 110.98. Okay, so that is we're going to cancel moles of calcium chloride, leaving us with grams of calcium chloride. So let's do that math. All right, so 6.3 divided by 36.46 divided by 2 times 110.98 gives me 9.59 grams of CaCl2. Okay, now we're going to go back and we're going to do the exact same calculation, only we're going to start with calcium hydroxide. All right, so 2.8 grams of CaOH2. Okay, I'm going to do the exact same thing. So we have to first convert from grams of CaOH2 to moles of CaOH2. So 1 mole of calcium hydroxide on the top. And then we need grams of calcium hydroxide on the bottom, which means we have to calculate the molar mass. So let's see, calcium is 40.08. Do this over here, 40.08. So this is calcium hydroxide. And then we have 2 oxygens, so that's 32. And then we have 2 hydrogens. Hydrogens are 1.01, so that's 2.02. So 74.10 is the molar mass of calcium hydroxide. 74.10. All right. Our next step is going to be our mole ratio. So we're going to have moles of calcium hydroxide on the bottom and moles of what we're looking for, so calcium chloride on the top. This is where we get the numbers from our coefficients. So calcium hydroxide is 1, calcium chloride is 1. And then the final step is we're going to go from moles of calcium chloride to grams of calcium chloride. And remember, we just did this step above, so we already have our numbers. We've got 1 mole of calcium chloride and 110.98 grams of CaCl2, calcium chloride. All right, so let's calculate. 2.8 divided by 74.1 times 110.98 gives me 4.19 of CaCl2, calcium chloride. Okay, so now here's what you have to do. If you do this problem, then you compare your two numbers, and whichever number is the smallest is your theoretical yield. So in this case, 4.19 grams of calcium chloride, this is our theoretical yield. And to find your limiting reactant, what you're going to do is you're going to go and you're going to draw an arrow back to what you started with. So if you look, calcium hydroxide, so let's slide this up a little bit. Calcium hydroxide is your limiting reactant, okay? What that means is HCl is your excess. Your theoretical yield is 4.19 grams of calcium chloride. And then to figure out percent yield, what we're going to do is we are going to take our actual yield over our theoretical yield times 100. Now notice that I changed this. Your worksheet may not say 0.88. Yours may say 18 something. Okay, but I'm going to use this number, and this is my actual yield. It says it is produced in the lab. Okay, so 0.88 over 4.19 times 100. So 0.88 divided by 4.19 times 100 is 21 exactly. So this reaction gave me a 21% yield. All right. Next question is just a simple theoretical yield percent yield calculation. I didn't give you very much room. But this says the theoretical yield is calculated to be 47.2 grams of iron. When a careless chemistry student experiments, the actual yield is 42.9. So our percent yield is going to be 42.9 divided by 47.2 times 100. So 42.9 divided by 47.2 is 91%. All right. Okay, let's flip this over. I think there's a couple more on the back page that we can practice. Oops. All right, let's see. In a reaction with zinc and hydrochloric acid, 140.15 grams of zinc chloride was actually formed. Okay, so that means they did the reaction. Although the theoretical yield was 143 grams. Okay, so this is our actual yield, and this is our theoretical yield. So we're going to take actual 140.15 over theoretical 143 times 100, and we will get 140.15 divided by 143 is, whoa, that's a good reaction, times 100. 98%. That's a really good reaction. All right, let's do one more together. All right. Let's see. We need to balance this. It's going to be 1, 2, 1, 2. Okay. Now, 15 grams of copper 2 chloride reacts with 20 grams of silver nitrate. How much silver chloride can be formed? Now, it's going to be really important for us to look at our formulas and figure out what's what. Okay, so copper 2 chloride is our first given, and then silver nitrate is our second given, and we're looking for silver chloride. So this is our unknown. Okay, so we're going to do two calculations. 15 grams of copper 2 chloride, CuCl2. I noticed some of you, when we were doing this in class, when I was walking around, I noticed that some of you did what I just did. You read 15 grams of copper, and you forgot to follow through and see that it's copper 2 chloride, which will make your calculation way off. Okay, so step 1, we have to go from moles of copper chloride to grams of copper chloride. So we need to figure out the molar mass. So copper is 63.55. And chlorine is 34.45. All right, let's add this up. 63.55 plus 35. Whoops. 63.55 plus 35.45 plus 35.45. I don't think that's right. Okay, 134.45. Okay. The second step is to use our mole ratio from the balanced chemical equation. And we're going to have moles of copper chloride on the bottom and moles of silver chloride on the top. And then we're going to look. So our coefficients, we have a 1. And for silver chloride, we have a 2. All right. And then the final step is to convert 2 moles of silver chloride. All right, and let's see, the molar mass of silver is 107.87, and chlorine is 35.45. So 107.87 plus 35.45. 143.32. All right, let's do our calculation now. 15 divided by 134.45 times 2 times 143.32. 31.98 grams of AgCl. All right, now we're going to do the second problem. We're going to start with 20 grams of silver nitrate, which is AgNO3. So step 1, is to convert from grams to moles. So 1 mole of silver nitrate. We need the molar mass of silver nitrate. So let's see. Silver is 107. I'm going to write this. So over here, this is AgCl. So let's do AgNO3. So that's 107.87 for silver, 14.01 for 1 nitrogen, and then we have 3 oxygen. 3 times 16 is 48. Let's do our calculator so I don't make a silly math error. 107.87 plus 14.01 plus 48 is 169.88 grams. So that goes here. Our next step is our mole ratio step. So we're converting from moles of silver nitrate to moles of silver chloride. So moles of silver nitrate on the bottom, moles of silver chloride on the top. If we look at our equation, we've got 2 moles of silver nitrate and 2 moles of silver chloride. And then finally, we have to convert from moles of silver chloride to grams of silver chloride. And that we already calculated down here, 143.32. Let's calculate this. We start with 20 divided by 169.88 times 2 divided by 2 times 143.32. 16.87 grams of silver chloride. Okay, so once again, when we end up with our 2 numbers, what we have to do is we have to look at the smallest number. All right, so the smallest number here is going to be the smallest number, which is 16.87. That's going to be my theoretical yield. All right, and remember what we do. To make an arrow, we draw from silver chloride and we go back. And in this case, we started with silver nitrate. Okay, so that means that our limiting reactant is silver nitrate. And our excess reactant is CuCl2. And then our theoretical yield is 16.87 grams of silver chloride. All right. And then it says, here we go, 11.3 grams of silver chloride is formed in the lab. What is the percent yield? Okay, so this is our actual yield. So to figure that out, we take 11.3 divided by 16.87 times 100. And we get 66.9. I'm just going to round that to 70% yield. Okay? All right. So hopefully we've been doing these gram to gram calculations for quite a bit of time now. So hopefully it's starting to make sense and you can go through these relatively quickly. All right. I hope this was helpful. I will see you in class. Take care of yourselves. Oh, and by the way, skip number 5.